Hello and welcome to the Introduction to RobotC Programming video. In this video, we'll cover a number of topics about RobotC, getting you familiar with how to set it up, configure it from the defaults, and program a robot for the first time, with the best robot default program as our target example. The RobotC is a Windows program, so you'll need a Windows computer. Anything from 7 all the way up through 10, probably 11 will work. A 32-bit or a 64-bit operating system is fine. You'll also need a USB port to connect to the Cortex and program it, and administrative access on the device so that you can install the software, which you can get at the link displayed on the chart. After you've installed RobotC, one of the first things you might want to do is change a few defaults. I like to change the menu selection to Super User to give me every possible menu option to set up and configure the robot. I also have to check and change the target platform. Often defaults to Vex IQ, so you'll want to change that to Vex 2.0 Cortex. So select Robot, Platform Type, and 2.0 Cortex. And while you're there on that pop-up, make sure the natural languages are not selected, and then you'll get a normal C prompt. Now you're ready to start programming. You can select New File and hit Save right away, give it a location and a file name, and then you're all set to start editing. And you can save that as you go along, and later you can close it, close the whole program, and open it up again and go back to that file and continue to work. And while you're coding, one of the first things that you'll do on your robot is decide which motors, outputs, and sensors you might be using. So you need to define what motors are hooked up to which ports. Selecting motors and sensors setup gives you a pop-up where you can type in motor names, and you can select the type of motor that is associated with the name. And then as you write your code, you can refer to that motor by name to send it commands. For our example, we'll go through defining default motors for the best robot. On the right side, you have a little table with the motor port, the motor function name, and the joystick channel that we're targeting to connect together with our code. On the left is the pop-up with the names filled in and the type of motor filled in. So the right motor is a 3-wire motor in port 2, and so on. So the editor with RobotC has several panes, and on the left-hand side there are functions that you can explore. You can drill down into function definitions, and then if you find a function that you want to bring into your program, you can drag it out onto the text window. On the next slide, you'll see an example of the while loop being dragged out, placed in the text window, saves you a little typing. The key there is the ability to drill down and see all the different functions that are supported by the IDE. And this slide shows the editor window, the RobotC program open, with the function pane open on the left and the editor window in the main section of the window. The Vex Controller has analog joysticks and digital buttons that you can use to provide input to your robot control. And you'll see an example on the next couple of pages of where the syntax to retrieve the handset positions are called out in code. As you build your program, you'll instantiate control flow. one of the first things that you'll need to do is establish an infinite loop. So the while true statement and put all your main code in between the curly braces is a good way to go. And you can also use functions to encapsulate functionality. So group things together that go together like driving with an arcade style, and keep your code organized. And here we have a simple example utilizing the default motor configuration. Notice at the top of the program the pragmas with the motor definitions. And then a little bit further down, you have two define statements for open and close to define the servo positions for open and close. And then there's define raise and lower and stop. Those numbers correlate to raising the arm in this fictional robot, lowering the arm at a much lower power because gravity is assisting the arm going down, and stop, which is 0 power. And as you look at the main code, you have the while true, so that's your infinite loop, and then the motors are just in tank configuration, so one joystick for channel 3 going to the left motor, and one joystick for channel 2 going to the right motor. So 2 joysticks on the handset, left to left motor, right to the right motor, and forward and reverse, and you would just drive this as a tank operating mode. The button 5D has been defined to open and close the claw. So if the button 5D is pressed, you close the claw. Else, if the button 5 up is pressed, you open the claw. And so you would have open and close the claw, or the servo in this case. And you see the words close and open, which were defined to be values earlier, makes the code more readable to use text, as opposed to just a number. Motor claw equals 20 is not very helpful when you're reading your code compared to motor claw equals close. And that's why we use define numbers into words, and then you use words in your programming. So you can follow along with functionally what you want the robot to do. And the final portion of the code there is the button 6 up and button 6 down, which were defined to raise and lower the arm or stop the arm. If you're not raising or lowering it, you should be stopping it. You don't have to stop a servo because a servo automatically stops. If it's not opening or closing, it is stopped. To get input from the gamepad, you use the Vex function, and you would pass this function either a channel 2, 1, 2, 3, or 4 for the analog joystick, or a button, and those would be 7 or 8, up, down, left, right, or 5 and 6, up and down for the back buttons, a button, and you would get back either a joystick value of -127 to 127, or a 0 or a 1 for a button. And a 0 means it's not pressed, and a 1 means that it's pressed. When you're ready to download your program to the Cortex, one common way to do so is to connect the laptop to the Cortex with an A-to-A USB cable. That'll power up the Cortex, and you can compile and download your program. You may get an error at first saying that RobotC firmware needs to be downloaded to the Cortex first. So the next chart will show you how to do that. So you shouldn't have to do this every time that you download a program to the Cortex, but there are times that the Cortex might get scrambled and you need to reload the firmware for RobotC. Or if you use another program such as EasyC to download to the robot, it'll download its own firmware, and you'll need to reload the RobotC firmware if needed. And you go to the Robot menu download firmware and automatically update Vex Cortex, and you should get a transfer dialog, and it should update the Cortex accordingly. And then from then on, you just do a build and download of your program, and you can do that multiple times. So after you've written your program and presumably compiled it and debugged it and got through all the compiler errors that you might have incurred, and you're ready to download it to the robot, you select the download to robot, and you get the status box that appears. And it should transfer to the robot. If not, you can go back a couple of charts and see to make sure that you've loaded the firmware or other issues that might have arisen. After downloading to the robot, the debugger window opens, and you can either select Start, and the program should start running, or you can cycle power on the Cortex if you don't want to be connected to the computer. Just unplug it and cycle power, and the program will start up. And in some cases, you may be asked to rename your robot. RobotC has the ability to store a 4-digit number as a robot name. And if you have to do this, it'll prompt you. Just go to Advanced Tools, under Robot, Advanced Tools, rename robot, and give it a 4-digit number. Any 4-digit number is fine, and this is not used during BEST competition, so it won't affect your robot performance for BEST. It just affects the ability to download.